Hello everyone and welcome back to the channel. In our last video, we explored the simple cyclic nature of round-robin load balancing. It's great for basic distribution, but it has a big flaws. It doesn't care if a server is overloaded. Today, we are diving into much smarter, more dynamic load balancing algorithm, which is least connection. This algorithm doesn't just pass requests along, it actively observes your servers to ensure your application's workload is distributed intelligently. So let's see how it makes your systems more responsive and efficient. Okay, so what is exactly least connection? At its core, the least connection load balancing algorithm directs new clients' requests to the backend server that currently has the fewest active connections, unlike round robin, which treats all servers equally regardless of their current workload. Least connection is designed to balance the number of ongoing tasks each server is handling. The philosophy is simple: the server with the fewest active connections is likely the least busy and therefore the best candidate to process the next incoming request quickly. Okay, how does it work? So let's just illustrate that we have several clients. This topic we have here client 1, client 2, client 3, client 4, and client 5. Maybe add client 6 and client 7 here, client 6. And can I add client 7 here? And client 7. We have 7 clients, okay. And we have our load balancer. And let's say that we have 3 servers. We have server A, we have server B, and we have server C. Okay, we have 3 servers, we have 7 clients. So initially, all servers right now have 0 active connections. So requests go from client 1 here. The load balancer will goes to server A, which has 0 connection. Right now it has 1 connection. Okay. Requests go from server 2, will hit server B. Right now it has 1 connection. Okay. The requests go to server 3, and right now the load balancer will see server 1 has 1 connection, server B has 1 connection, server C has 0 connection, so it will redirect it to server C. So all servers have 1 connections right now. So when client 4 tries to send a request, the load balancer might pick server A or use a secondary type breaking rule like round robin if all are equal. Server A has now 2 connections, not 1. Okay, and we have client 5 send request. It goes to server B. With server B right now have 2 connections. Okay, and we have requests from client 6. Client 6 here, server A has 2 connections, server B has 2 connections, server C has only 1 connection, so the client requests go to server C, which have 2 connections. So meanwhile, client 1 finishes its task. Let's say that this task is finished. So let's just remove client 1 and let's just move tasks, just 1 connection. And we have here client 7. Okay, and client 7 now will send a request to the load balancer. So right now in the load balancer, server B has 2 connections, server C has 2 connections, server A has 1 connection. So the request to go to server A because it is the least connection one. This dynamic approach ensures that new work is always directed to the server that seems most available to handle it, leading to a much more balanced distribution of active workload. What are the advantages of that? This connection offers significant advantages over simpler algorithms like round robin. First, better load distribution. Its primary benefit is that it leads to much more balanced distribution of the actual workload, especially when requests have varying durations. Servers aren't just getting an equal number of requests, but an equal share of the active work. Number two, improved performance. By preventing any single server from becoming overloaded while others sit idle, it leads to lower overall latency, faster response times, and more consistent user experience across your application. Number three, handles varying request duration. If some requests are quick API calls and others are long-running database queries, least connection adapts a server processing a long query won't get another request until its connection count drops, while ideal servers pick a new work. Yeah, it's great for that. Number four, effective for state-aware protocols. Since connections often persist for a duration with protocols like HTTP or WebSockets, this connection is highly effective at balancing these long-lived connections. Okay. Let's talk about the disadvantages. The first one, it requires connection tracking. The load balancer needs to actively track the number of active connections for each backend server. This adds a small amount of overhead and complexity compared to stateless algorithms like round robin. But two, not always perfect for CPU-bound tasks. While it balances connections, it doesn't directly measure CPU usage or memory or network I/O. A server with few connections might be bogged down by a single CPU-intensive request. In such cases, other metrics-based algorithms might be more suitable. Number three, potential for cold start issue. If a new server is added to the pool, it starts with 0 connections. This connection will then rapidly send it many requests, potentially overwhelming it initially if it needs time to warm up its cache or JIT compilers, for example. Number four, persistent challenges. If session sickness is required, like a user must always return to the same server for the duration of their session, this connection typically needs to be combined with other mechanisms like cookie-based persistence to maintain session state, which can complicate the algorithm's effectiveness, to be honest. Okay, so in conclusion, the least connection load balancing algorithm is dynamic and intelligent choice for modern application with varying request duration and workloads. By actively distributing new requests to the least busy server based on active connections, it ensures a much more balanced workload and ultimately delivers a more performant and reliable user experience. While it adds a bit more complexity than basic round robin, its ability to adapt to real-time server load makes it a preferred algorithm for many production environments. So yeah, that's it for this video, and yeah, see you in the future.